I got kids with.
You
got a 43.
A 7.
So,
I actually went to 7. I'm too parched up.
no, you know those are fake. Okay.
I love them at
Perfect.
Why?
Yeah.
They're not just, they just.
I had accidentally bought them one class.
Oh, yeah.
I didn't read, I just grabbed.
They have
I'm like,
How
about
Yeah, we're
like, give them to your friends then.
That's too
We're
far.
we're gonna go ahead and get started. Thank you, Mr.
Just keep it on him.
Yeah. I have heard that some people need to leave a little bit early. Roxanne has a flight this afternoon as well.
It's cheaper to fly than to drive. So
Yeah.
figure that out.
From Baltimore.
From Baltimore.
So we're going to go ahead and get started. I am recording again, so we can post it on the website. And, yeah. So thank you for coming on a Wednesday instead of a Tuesday. My days are all screwed up right now because of it, but it is Wednesday. And we'll go ahead and get started. We are going to start with, we're going to go over investigation 7. I know some people have done 5. Some people have not done 5 yet. For those of you that have not done 5, 5.1, looking at it, who's not done?
Yeah, first of all, where are people? Like, are you on 4, 5?
We just tested on 3 and 4 today.
3, 4? So
We
you're
just tested on 3 and 4 today.
Oh, 3 and 4. I
Yeah,
gotcha.
so
So we're starting 5. Okay. Which
So
is
we have to give we were told we have to give a CSA for our school, so we won't start 5 until end of next week.
okay.
I just did 5.2.
Okay.
We're doing CSA, so I'm finishing.
And this is, okay.
Finish
It's in
before.
Pause somewhere.
What about you guys?
That is?
Where,
5?
We're just
finished testing.
Okay. So 5.1, looking at 5.1, if you have not done it yet, is not something that we need for Virginia standards to cover. So please don't worry about 5.1. 5.2 is where you should start. And because we are not doing investigation 6, that's where conduction and radiation would have come in. Roxanne and I talked today about it, and we feel like the most natural fit for radiation and conduction would be in 5.2 with convection. So we make that, that's the only adjustment that we have to do. So, Shonda, if you guys have already done 5.2, you might want to go back and touch on those two.
You want it?
Concept
Are we doing 5.3
Did you make
or
that?
no? Because they don't.
I can look at 5.3. We didn't.
I forgot about 5.3.
5.2. I mean,
It's calories.
Hold on just a second.
And
Yeah, we don't go over calories either.
So you don't do
Yeah,
the,
so just 5.2, and that will save some time to catch up.
so that's actually exactly how it
It's like
was.
the next episode.
So I'm doing.
So the investigation 5.2, Shonda, how long did it take your students to do?
Say that again?
5.2, how long did it take your students? Just one day?
She
Or?
just did it in one day.
Yeah,
Because it was the reading.
gotcha.
Right, that's what,
There's
you
not
could
a lab
almost,
that
I mean, I was
has
wondering if you could
Yeah,
do the
it's
part
good
in
stuff.
5.1 without doing the calculations, you know, because what they're supposed to see is in investigation 4, they just do hot water and they do cold water separately. Then in 5, they put the two together and talk about heat transfer and what happens at that particle level. And that was the idea of why you calculate it. So I don't know if
What I
doing
did
and
when
talking about it, but go ahead.
what I did when I wrote a PowerPoint just for 5.2, and instead of it using the water, the hot and cold water, I referred back to us putting the sphere on the hot plate and talked about that in there instead of where it talked about hot water and cold water. I talked about that instead, and then brought up the hot and cold water with the virtual, because there's a virtual
Right.
one
on
of
there.
those two.
Okay. Yeah, and
So
so,
that-
yeah, and we'll have to, Shannon and I were talking about a couple other things on like some places where, like we talked about with Adams and then some other places on where might be better fits, just like we may relook at like radiation stuff, but right now 5 looks like the best place to put that in, some other places and things like that. So there might be some tweaking for next year just because of taking some things out. We might add a little bit more in 5 because we're taking out 6, and maybe just add a few things and stuff like that. But yeah, so for right now, I think we're just gonna go with that. Does that make sense for people? All right, so then based on that, we're gonna look at investigation 7. Investigation 7 has 2 parts. It's solutions, and so what students, so this PowerPoint, just so you know, because I know Mallory, you were using some of these. This one is a little bit more from the teacher perspective, a little bit. Some parts, even though it still addresses the step, so some of the things will obviously need to be taken out. But in investigation 7, students investigate what it means for a substance to either dissolve or melt. And this is a really tough concept for students, the difference between dissolve and melt. That happens in investigation 7.1. Then in 7.2, they talk about and they compare solubility of 2 substances, something that they're already used to, calcium carbonate and sodium chloride. And then they talk about separating mixtures to recover the original parts. So that's a big overview of what happens in investigation 7. So now what we're going to do is go ahead and open up your notebook. Go ahead and put today's date down. And before you put the focus question, or you can go ahead and write the focus question down. What is the difference between dissolving and melting? And that really
You want any computer paper?
What do you need?
Like paper?
Oh, do you need for a notebook?
Yes,
That happens, right?
Need some more. Yeah, we're missing. They're testing.
They have a modified schedule.
So in the last investigation, well, not necessarily in 6 per se, but also in 5, students were looking at energy transfer, and in this we're going to look at something different about heating. And so you're going to work with solid chocolate candies. So we may need to remind students the safety number, which one says, hold on, report all treatments, clean up, always protect, never smell, never put materials in your mouth. So number 3, we may have to remind students, because this could be quite tempting to do. And so what we're going to look at is what I'm going to ask you. Hello, welcome back. So what I'm going to do is, here's a strategy. And again, this is taken right from the investigation guide. And so what I'm going to do is give each of you an index card. You can use either side. And I want you just to do a quick write, which is one of the strategies, is what does dissolving, I don't know why you need 2. What do you do? Welcome back. Does it feel good to be back? You don't have to answer that, right?
Yes.
All right. So I'm gonna ask you to see what this is again coming from a student perspective. You're gonna ask them about what is dissolving. So we're gonna ask you to respond to the questions. I'm gonna ask you to, what is dissolving and what makes it happen? And what is melting and what makes it happen? So thinking of those 2 questions, and you can write as if a student would write that, or you can write in your own terms. We have an extra notebook too if you want. Okay. give you just a few more seconds to kind of write. And so one of the things they can do on this quick write is then they can take that index card in their note and put it in their notebook and just trace around it, and then you're gonna collect that quick write. So then they leave space in their notebook. So then when you give it back to them, they can go ahead and revise it, they can add to it, they can change it, or whatever you want them to do. So if you wanna just take a minute, draw a little space where that index card is, I'm not gonna collect it, but one of the things I wanted to point out to you is this is just to see where students are, and you'll probably find, and I've got some examples of what students may have said, is these quick writes will be revisited, but they're really not revisited where the students will come back until after you finish all of 7, so not until 8.1 is when you'll revisit it. So here's some student responses, so just take a look at that and see that's pretty typical. So what do you notice about some of those responses?
Can you turn the light off for a second?
Just hold on.
Good minute.
Oh, who's someone? I think someone here. Go ahead.
They all
Alice.
associate melting with heat.
Right? What else?
I thought, the one in the middle says dissolving and melting, they think they're the same thing.
Right.
Yeah.
I mean, they're basically, in this one, they're saying the same thing. This one, they're kind of saying the same thing, but maybe in a different way. So they don't really have an understanding, or is dissolving with melting. What else?
They're using a solid and liquid, so they have no gas, but solid and liquid.
Right. So dissolving only happens in a which makes sense, right? And that could be one of the things too when we look at this investigation. The idea here is we're gonna really hone in on the idea of dissolving and melting at that particle level, just like we looked at energy transfer at the particle level, so that becomes really challenging for students. Right? So what most students think is so this is really what we want to do. This is where we want to work at. Right? So just kind of giving you an idea. So we're going to actually do investigation 7-1, right? And so if one person from the group, I put up enough materials so that each group of 2 can work independently. So at this table, you should have 2 sets. This table, you decide. If you want to have 1 set, have 1 set, and same there, all right? And so based on that, this is, so disregard this, because this was set up as if you had a material station for groups of 4. So let me just go through. What I'll do is I'll give you this, which you can also give to students so they can learn to read direction. So I'll just give a couple per table. So these are the materials that you're going to need. Can you take that? One of the things, so why don't we just take a minute, and you may have to obviously go through the directions with students on what they need, what are the materials. So I kind of have it set up where, and they show the picture. So here's the candies. What I did, and again, you might have to think this through. I used M&Ms. M&Ms work the best. They don't have to be an M&M, but they work the best. Since they're going to use 4 of the chocolate candies per group, I put the same color in there to eliminate a variable. Now, it doesn't mean because I didn't have all the same color, even though like if you went and probably bought the Halloween ones or the Christmas ones, you'd have a lot of red, a lot of green. You could do that. So then you can have them have discussions on, do you think something melted quicker or dissolved or whatever based on a color. So you could throw that in. Go ahead.
What's different candy because I have nut allergies and we can't have M&Ms because it's contains the same factory as a nut. Like I have two kids that shrimp. Like I can't put that in the room.
Is that only if they eat?
No, they can't be in the same room. Like if they touch it, they have to go straight to the nurse.
Then how about if they wear gloves or they don't touch it? I'm just asking. I don't know. I don't want to cause issues. Safety is the utmost importance. So some kind of a chocolate. Go ahead, Shannon.
I'd have to look at the ingredients, but I do know that there's
And we can.
sugar-free candies that are like M&Ms, but they're not M&Ms. I don't know if those
It's
have.
not the sugar-free. It's
No, I'm saying, but they might be manufactured differently.
It says may contain peanuts.
Yeah, because of that, I got two kids that
Oh, that's right. I was
like
wondering.
just.
May contain.
I can't have that even as like part of my snack because it's a nut in the room.
Okay. So what we'll do is we'll think about, but you need something that will melt and
That's
dissolve.
what I'm asking.
and
Like,
so-
is there something else?
I don't know. We can definitely think about that. But I guess the question would be is if they don't touch it or eat it, are they safe? No, they're not. Okay.
His allergy is so severe he can't.
Okay. And so then we'd have to, I don't know then quite often. I mean, because we'd have to look into that. So
Pure dark
That's
chocolate
those little
would be
kisses.
expensive.
what's
The
that?
little chocolate morsels.
Yeah, have the candy coating.
They- Do they have some with the candy coating? We'll think
Yeah,
about
I
that.
can.
But I
look
mean,
up
I
some.
know in other, when they mentioned, they say they could wear gloves or they don't touch it, and obviously they're not eating it, and so that's normally safe, but we don't wanna put any student obviously at harm.
And
So-
remember that can be as long as it's $25 or less, that can be reimbursed by your IL. So you don't feel like it has to come out of your pocket right now. And candy's on sale right now.
Candy is on sale right now, 30% off, yep, or wherever. So decide how you wanna do that. I already put the candies, 4 of them in
We
there.
can look up some.
Because I felt like if I had a jar of candies, they may not take 4. I mean, imagine that. If I was as an adult, I might not take 4. If I'm like, yeah, I only need 4, I might take 20, right? Alright, so you have those. So go ahead. I would go through the materials. I would go through the setup together as a group to make sure they understand. I think the drawings are very nice and self-explanatory. One of the things that they do is pour about 100 milliliters of hot water and cold water. So I have the beakers here. So this is a good time to assess them on being able to measure. You could set up a water station here. I have the cold water. I have them in the water bottles. And then over here I have the hot water ready to go. And I'll turn that on in a second. And it's all set. So go ahead and read through the procedures. Go ahead and the getter can come and get the materials. And then we'll have the water ready.
Yeah.
And I will make a note.
You getting the getter.
No, we'll just do it. We don't want
I'm looking it up right now.
There you go.
What else could I use?
Well, I'm sure there's stuff that can be used that isn't.
The other classes I couldn't, like, where his class comes in, like, try to disinfect the room, but he's like,
Wow.
I'm thinking dark chocolate because it'll melt at 93 Fahrenheit.
so just.
Hers is more, whether it has nuts or not. And that probably doesn't have nuts.
It won't,
They-
not if it's, yeah, of course it's gonna be expensive if you buy the.
But you don't need that many.
Yeah,
Yeah.
it's for that one
No.
class.
So if you bought, what is the Hershey's semi-sweet, is that pure, is that 100%?
Yeah, we're supposed chocolate chips.
No,
Yeah, but wait, what about bacon chocolate?
that's what I'm saying, the Hershey's baking.
York peppermint patty.
Which would be-
I guess I don't know if they would melt them.
I don't know
But
that
what-
the inside
But
chocolate
we're,
chips for cookies.
yeah.
No,
No,
chocolate
you need a
morsels.
coating.
Yeah.
They need a coating.
Oh, they need that chocolate. They keep.
Yeah, there's a
candy
big, the big reason is that coating becomes important. Is it warm enough?
Can they watch it like
And you need 150
FaceTime?
milliliters.
Skype it? They can Skype in?
So I don't think you have
No.
enough, right?
an allergic person.
Oh, I know.
Yeah,
Go in
but
another
at the
room.
same time, like I'm thinking, like from
I think
the
you
perspective of that kid, if I was that kid, like
haven't.
great, I'm totally being neglected out of this, and I can hear the parent coming back like, "You denied my kid an opportunity. Why didn't you come up with an alternative?"
We're gonna look up. I'm looking
No,
up.
I'm not. I'm just.
That is alternative to be watched. To watch it, that's alternative rather than being
It's been a
excluded.
day.
They're included. They're not
You
excluded.
can obviously take paper towels. And honestly, there probably isn't peanuts in there, but
Put them in a bottle.
they cover themselves. Attorneys cover you. And get that in there.
Well,
Make sure they know what they need to grab, right?
Right, make sure they're not feeling left out.
Yeah, we'll have to.
I was gonna say, have you told her about the new treatment for peanut allergy? I have a couple friends whose kids
Slowly
are
exposing them to them.
Yeah, now they're not
A friend of mine is one peanut M&M a day is what her son's getting.
My
So,
doctor told me to give Elliot peanut butter.
That's why I was saying.
Like,
Yeah,
at
he
6
accidentally did it at 6
I
months.
mean,
Yeah,
This
well,
is pretty
she
well
actually
done.
told me
I
at
mean,
4 months, but I never
I
did.
mean, all
I
you
just
have to
haven't
do
done
is take out, you wouldn't
I
say,
have
this is what students would say.
Such a severe reaction.
Alright, so we
He
should
got in
see
the car
you
with someone who
getting
had
this set up.
And
And
now
please
he's
be
not
careful at the
Wow.
hot water station.
Matt gave Gunner peanut butter chocolate ice cream with Reese peanut butter cups on
Oh, I got 4.
at 6 months old.
Well, I'm like, no, like you're
Nowadays they're
supposed
back
to.
to telling you
Yeah.
you should.
Yeah, she said get a little peanut butter, put it in his cereal, like flavor his cereal, and give it to
Yeah,
him.
just like those other companies.
I was like a nervous
I
wreck
haven't
that
done
whole
it yet,
night though.
but-
I was like,
Excuse me.
Shannon, put some colder water in the front of the screen now. On your-
oh, my screen?
This is gonna-
Oh, thank you.
No, just put it in there.
It's a long hot water.
When I did the start, because
And
my
then
water was really
one
hot,
was
she
cold
would,
water.
I just wanted to sit in the styrofoam cups while they the compress or the contract.
That is under.
Oh, yeah, 200.
No, you only put 100 in it. Just being a jerk.
And it will melt a little bit. Half my cups are halfway.
See, that's why you want them to have it at the same time. So they can see hot and cold at the same time.
Right,
Wait,
they're
wait.
melting the cups that are
Oh,
non.
now you want me to let you use it, huh?
Let
Oh,
fill it
it
up with hot
shouldn't
water.
melt
Go
if it's
ahead,
not
go
too
ahead,
hot,
do
is
your
it?
One of the problems.
Okay.
Oh,
So
did you have
far-
it boiling?
No. It's just in
Okay.
a coffee pot.
Cause this isn't
Yeah,
gonna
maybe I
melt.
Okay.
Yeah, if it's boiling, yeah, it'll melt them. And it
Yeah.
No,
says that.
it wasn't boiling.
Yeah.
It just
Yeah,
so
Mine
now
melted.
hot water dispenser. I got you make cups off of it. and-
Oh, it's probably too
Here
hot,
and-
so it may just have to sit for a
Hold
minute.
on.
That's what I did.
Yeah.
I'm trying to
That's
get a
all.
measure.
Oh, do we have 2 of these?
And so you wanna try to do
Yeah,
these
we
at
can
the
share.
same time.
We can
So
share. We don't
you might
need to
wanna
do
think about
two
time.
sets,
Has
right?
anybody decided to see how long it takes? And you should be observing what's happening.
now.
I'll drink it.
And when you're observing, you can draw what's happening.
Isn't he fine?
If it's
What
not
is
like
it?
a student, if it's too hot, it will.
Oh, it's
supposed to be,
melted.
so that's too hot.
We melted the
It's greater than
Yep,
Sandy.
it's too hot. If it's greater, yeah, so teacher tip,
Okay.
so I'll get it.
If you're putting cold water.
Do that, that's perfect.
All
And
right.
so Valerie had a good idea of, or we can just wait a minute, is you can have it set in a styrofoam cup for a little bit and then set it into the hot water, because you want them to observe the hot and the cold at the same time. Alright, and what you're observing, go ahead and draw what you're observing. And so you'll need, oh, you're each doing, okay, so you're good. Okay. So you're good. I had it set up so you could each do your own set, but you guys decided to do it as a group. That works. That works. I'm gonna go ahead and
You guys
hit
want
these.
that open?
Does anybody else need to measure the water?
Okay.
So,
So put,
straw.
Oh, I got.
put small. Make sure the small cup doesn't have water before you brush.
I'm sorry. Would you like one of
sorry.
these?
So we want it to
No, I got 4. I took 2 back. Where's
Okay.
one?
one candy,
What?
one at the bottom of each cups of water.
Yes.
Yeah, perfect. And then one, there you go.
Perfect.
So where the plant dissolving and melting.
And here's some questions while you're observing. Some things to keep in mind is you might want to think about what happens to the colored coating. So as you're watching this, maybe timing, make some drawings. I like your drawings there.
I just asked one of my sorority sisters has a son that's allergies, and she's active in
that community, so I just asked her the total situation, what we're doing and why, and see what she can come up with. If she, if anyone knows, without me looking up on the internet, it would be.
Oh, I'm just like I said, I got that one kid. He's one of those kids that's so engaging, who loves this kind of stuff, and I don't want to sit there and say, well, sorry, Merrick, you have to go sit in another room for this.
Well, we're gonna see what we can come up with.
It doesn't have to be chocolate.
Yeah, we'll be talking
What else would melt?
Better. Without being too hot.
Skittles would, and I was thinking Skittles, but those wouldn't melt.
Yeah, those don't.
Skittles will dissolve,
Will
but
dissolve.
they're not gonna melt.
Right.
So I don't know what else is gonna melt.
Maybe there's
some,
but there might
I
be
don't
a
know,
candy
those
that
mints.
for students that have, or kids that have allergies.
Oh, white mayonnaise.
Because you're looking like a nut.
No, I'm trying to.
They're like, they look like Hershey Kisses, but they're colored and.
Are they made by Hershey's?
Oh, Purcell's snow caps.
Yes.
Oh, snow cap.
Something like that would probably melt.
It had a moon phase question, genetic engineering.
But are you gonna see the melting of the?
I don't know if they would or not. Same.
Yeah, yeah, we're trying.
No, because I figure after this, like, oh wow.
Has anybody been timing? Oh, good. So after, we're gonna let this
This
go.
is probably going to involve a phone call to the mom just to double check, but I'm, if the kid tells me this stuff and I'm trusting him, he knows his allergy really well. Because if a kid in the first block gets a fever, he has to go straight to the nurse.
Well, some kids can't even like inhale the
Is
smell.
anybody surprised
Yeah,
that
which
chocolate
is-
hasn't melted yet?
Yeah,
Which
and one of
tells-
the things
which
we want to
tells
point
me
out
that
is
there's not a whole lot of chocolate in it.
is that we want to make sure that we just, I forgot to mention, we don't want to move the cups around.
Yeah.
Well, once we did the cup and beaker,
Yeah, but water.
now we would jack the temp up as high as we can possibly.
You don't want to, that's not, I guess the idea is you just want warm water or
Can we
hot water.
just, can we do the hot one in a styrofoam cup?
You can't see it then, no. So the idea is, you guys are fine, what had happened was it was too hot, so you can let it sit in the styrofoam until it cools down. You could have them measure the temperature. Once they measure the temperature and it's at the right temperature, have them put them in the plastic cup. Because you want them to be able to see it. That's important.
Is he listening?
And so adding some color to your drawing would be helpful. You guys got some different colors going on there. What do you notice in the top cup?
So I was supposed to right.
So is this hot water top cup, is this hot water cold?
We're gonna hold off on that right now. I'm just gonna have you draw in your notebooks what's happening.
A picture's worth 1,000 words when you use words. Either one, pictures or words.
Pictures or words. So if you want to, go ahead and draw what's happening, but make sure that you include what's happening in the top cup and the bottom
Is the
of the
top one the
cup.
hot one? This one's hot, this one's cold.
Is there a difference between the hot and cold?
Yes.
Okay, what's the difference?
What,
What melted?
I'm gonna give you a few more
Yeah,
minutes.
top cup though.
I think we're not done with the experiment.
5 minutes. So we're gonna look at about another minute or so while you're observing.
And that's, I mean,
well, that's what's coming up next. We're supposed to squish it. So is it pure chocolate? Is it 93?
I'm not a chocolate fan. I don't know.
I'm sure. It's pure chocolate that melts at 93 Fahrenheit.
top cup's
Obviously,
nothing, bottom
not
cup's
chocolate that's got a bunch of other stuff in it.
hot cup,
But we're not looking at when, we're talking about looking at melting and dissolving.
yeah, candy shell.
Whether
Yeah, it's
it's
brown.
dissolving right now
Candy
or
shell
melting.
is melted. Melted?
Or neither, or both.
Well, both are dissolving. But I wouldn't say that's
Bottom cup's
melted
hot,
at all. Would you?
cold, cold, color.
Well,
I don't think we'll know.
the only way we can know is when we take it out.
So we got another about a minute or so. So what's happening to the color coating in the water? What do you notice?
Oh, it dissolves.
Getting
and then
darker.
Because it's mostly sugar.
So concentrate a little bit.
So did it come off the candy? Think about what a student would say. They may not say it dissolved. They may say something like, right, it came off the coating, came off in the water. They might say something like that. What's under the color coating?
Brown.
Brown? Okay, probably chocolate.
Division, it didn't do well.
Well, hopefully they don't say that.
They will.
How about the candies that aren't in the water? What's happening to those?
Nothing.
Well, the one crack.
Okay, so go ahead and I would note that. And which one cracked? The one in the warm water, or hot water, or cold water? All right. How about anybody else? Nothing happened to either of yours?
No, our candy should have melted off the dissolve.
Candy coating?
Dissolve from the hot one. And it's like lower.
It's
Okay.
so that tells me it's
Cold is lower.
Oh, yeah, and it was, what's this stuff? What's this? And it was like,
Don't
Of
stir,
course they
float.
did. That one, yeah. And the plunger.
Yep.
And the tube. Of course they did.
It's like a white
It is.
filmy stuff.
They are kids. It is what it is.
Where? Oh,
They can't.
I found
white
out today
filmy
that
stuff on top
cheesecake
of
is something eggplant.
Yeah.
Is something
Oh,
Oh,
eggplant.
eggplant.
Water
too.
no.
Oh, is it now?
What's happening now?
Okay.
It's an
It's
emoji
like
on your
white substance.
Mm-hmm.
Okay.
I use that one in my life.
Alright, we're gonna give it one half.
Yeah,
Where
it's
are
still
we
on
on
the
the
outside of
timer?
the candy. It hasn't sloughed off yet.
Cracker's cold.
Well, I also picked that one up.
8 minutes. Okay, we got a little bit longer.
More, so I might have sloughed
Does
off.
it look any different than it did when you first started?
Yes.
Well, how does it look different?
The
No longer looks appetizing.
Alright, what else?
the candy coated stuff is off.
The candy coated is off on both of them?
Mhm.
And off where? Just in the water? Not in the water?
It's not completely off the cold one.
Okay,
It has
so
a
it's-
white film on
So it still has a white film on it? What else do you notice?
I know, too.
Alright, so now what you're going to do is, I gave each of you a paper towel. You're going to make a grid on your paper towel. Hot water, cold water, cup, and water. And you only need one per group, or one per, so.
Killing trees.
Let me find my shopping list.
You can use the paper towels that you have in the bathrooms too, so we just happen to, we just had these. What's that?
That's one of my problems.
Why do you use these?
They don't absorb anything.
You don't want them to absorb actually, so all they are is just a place where what you're going to do. So first let's go back to some of these questions, alright? What happened to the color coding in the water? It dissolves where?
Then you can still.
Did it dissolve in the hot?
Yes.
Did it dissolve in the cold?
Yes.
Alright, but where did they dissolve the same?
No.
No.
Alright, what would you say how they dissolve then? Go ahead and someone.
Faster in the hot.
Faster in the hot, alright? What is under the color coding?
Some kind of a white film that
So-
we can't identify.
Some kind of a, did others see that?
Yes.
Alright?
I can see it over
Do you still see it?
here. No.
No? Some say yes.
In the cold.
In the cold, you might still be seen. What happened to the candies that are not in the water? This group already answered something. Yours cracked, but which one did it crack in?
The hot one.
Alright, how about anybody else's? Did yours crack?
No.
So what now we're gonna do is, you're going to go ahead and use the paper towel and go ahead and take the candies out and place them in the correct place. So make sure you,
I think we do have spoons.
and what you're going to do is once you get the candies in the correct spot, you're gonna test the hardness of the 4 candies.
Spoon. She might have a spoon. She's grabbing them right now.
And then go ahead and record your observations. So you can test the hardness. So if you want, go ahead, you're gonna put all 4 of them on there. Oh, I'm sorry, I forgot to, you didn't take the container. So this, you can take the,
I'm glad you dumped that for me, so I know what happened.
or you could take them out with a spoon, but here's the water to take the other ones out. So go ahead and just
This is
dump the water in there and try to save the candy. I can get you a spoon too.
Okay.
Let me get a little bit of that.
Yeah, top off.
Bottoms up.
Cold, so.
No. Lab safety first.
Number 3.
This one right?
Kiwi.
Yeah.
Delicious.
Oh, yeah, it's okay. We ended up just doing this. Thank you, though.
Do you guys need a spoon?
Now we're good.
You good?
Alright, we got the 1 liter container.
We do.
That one's
Alright,
milk.
and so test the hardness.
Using what?
Just use your finger gently.
Oh, no.
If you don't want to,
No, I mean, just for that. I'm not there. All the want to wash their hands.
well, you only have the
Great.
person first.
Nothing.
Or you can
Ooh,
use
that
the, well, then assign.
Squishy.
So what are you noticing?
Squishy.
Oh, no, I can hear it now.
Oh, I know. I know.
I'm gonna be laughing.
On all 4 of them, notice the hardness.
And they're
What are you
gonna say a real
noticing?
word. Yes, they are.
So go ahead and add that to, I know we can use, talk about what's happening. What did you notice?
Head into your name.
No, but I.
Okay, what are these?
Oh yes.
The M&Ms in the
Hot water.
hot
They
water
say loud.
were
Oh,
squishy.
Mike
Even the
didn't
one,
know.
the cup that was up,
Yes.
alright?
Too hard.
What did you notice?
Oh, I ain't say
Were
last
all
night,
your
did I?
squishy?
I'm good.
Only the hot one.
Just the
Kids are
hot,
gonna squish it.
well,
I'm
and that's
trying.
fine, you just wanna see, were all your
They can
squishy?
fly across the room 'cause they're fun.
No.
Alright,
Ones we're not.
so go ahead and add to
Sorry,
your,
it was a bad day.
This, my friend, is
alright, so right now you're going to record your observations in the table and don't go ahead and answer, don't go to the conclusions. Actually, you don't even need you don't even need to do this sheet if you don't want to. They can just draw in their notebook or put the notes right in the notebook. That's something for you to decide, but a scaffold for someone else, for some, might be okay. I think the more they can draw, the better, but others have to feel comfortable with that.
Yes.
So go ahead and make sure you have your observations in your,
Hot water.
candy coating's pretty gone. Oh, no.
Record.
it's okay, you guys can go ahead and record.
Oh, candy coating. Melted, cracked.
So if hot water got completely gone, cold water slower than hot water, but completely gone. Hot air nothing, cold air nothing. Chocolate.
The hot air got a little squishy.
Hot air.
Not noticeable.
Oh, I
Squishy.
messed it up.
Let me have that right here.
Squishy.
I have it right here. Yeah.
I described it to my students.
So for chocolate and hot water, I said nothing happened.
Chocolate in hot
No,
water.
no, it did.
Oh. Chocolate in hot water.
Chart is done.
I guess it was melted.
Me.
Okay, let's say melted.
Cold air.
That was before. I put that before we actually squished it.
That's a good idea though.
Are in the top,
Very soft.
the small.
The one in the cup or
What
the-
happened in the small cup? What
So the
happened in
chocolate and hot water is very soft,
Yeah.
See what I mean?
So this was.
and this one was
So these
semi-soft.
two, this right here
Is there air? Okay.
and this is water. So I just.
Yeah.
This is a short. Hot air. Cracked. Cold air. Hard.
This, oh, crap. And then it's like, crap. So
Cold air. Hot air. Chocolate. Have to
Look
be
up,
done.
boom.
You guys
30
do the,
tops.
what is
Not
dissolved?
reading right as well last week. So that's what that 2
Leslie, we just had that conversation today with Roxanne about the midterm, so it's good to know.
Yeah.
Well, what?
We're gonna, after you
about
guys
the Google
finish your
image.
observations, I'm gonna have you guys, once
That'll,
we
that'll
have
probably be
little
a better
conversation,
quality
what is
picture
melted,
than
you
having
guys
to
are gonna
cut and
either
paste
draw,
to
describe it,
Yeah.
talk about.
take a screenshot. Did she already take y'all's?
Yeah.
I did, and I was just finishing. Once we finish our observations, that
No, that cup
actually
melted.
dissolving,
Okay, I'll pour it
melting,
out.
and you
Thank
guys are gonna think about the similarities and differences between the two. dissolving and melting. All right, who needs a little bit more time to put in your observations? So when you put for this, what is that? Nothing. Nothing as in it stayed the same?
Stayed the same.
Okay.
No change.
No change, I like that. Alright. You guys have all your observations? Alright, so let's think about what's happened here in this investigation. So first we're going to look at dissolving. So what happened to the color coding? You guys already started this conversation, but again, remember these are 8th graders. So what happened to the color coding? And using the word, thinking about, did it dissolve or melt? And what do you think? You can talk with your group.
Right, so majority of stuff that was in hot air or hot water, something really happened. So the can coated candy in the hot water dissolve a lot more than 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 the cold water.
Well,
Then the same would go for hot air.
when you add heat.
I guess you would say it would melt more in the hot air, melts more than in the cold air.
But as far as the coating, it just dissolves because it's all
It
sugar.
dissolves,
Right.
it maintains its own.
Melts.
Like it's still candy coating
Oh, I see what they're trying to do.
dispersed in water,
This
right?
is liquid and melting on
So we should be
liquid.
able to set if it's dissolved,
No, I
we
don't
should
know
be
what
able
it
to
means.
back
I did that.
to that candy coating technically.
All you have to do is just
But that's
back
not
like
the
water.
I thought you were just trying to say dissolving really just deals with majority just liquid.
Alright,
And
so
they're gonna think it did.
let's think about what does dissolving mean. So I heard people say that the coating dissolved. What does that mean?
It went away.
It went away, right? And that's probably, but did it go away?
No.
No? Why do you say no?
Well, it made a solution particle by particle.
Alright, how do you know it made a solution?
Because the water turned blue.
You could see it, right? And I heard something else. Go ahead. The water turned blue.
I'm
So
included.
it did it really go away? No, it may not have gone away, but what did it do? It did on the candy. Where did it go off the candy, right? And where did it go?
Into
Into the water. Where did it go in the water? Say it again. At the bottom, right? That's key because you can even then leave that candy in that water and look at it later and see if it changes. All right, so it's at the bottom. Did they look the same? So the idea is you want them to think about the colored coating. Where did it go is key. So it's in the water, but is it dissolved in the water?
Yes.
It is. All right, so what we are going to look at is when a solid material is placed in a liquid and the solid disappears into the liquid, we say the solid dissolved. Did anything else dissolve? Talk about it. If so, what's your evidence? Did anything else dissolve? What else is part of that candy?
That white stuff?
The white stuff. The white. So you actually had like a whatever color you used, a color coating, and then you had a white coating, was kind of white, and then did that dissolve?
A little bit in the hot.
A little, how about
Not
others?
so much in the cold.
Not so much in the cold, all right? Do you think it would dissolve? So what I want you to do is talk about if anything else dissolved, and if so, what's your evidence? You already started about the other coating, which was white, kind of gray, kind of a dingy color. Did anything else dissolve?
Find that simulation of things.
What
We
about
don't
the
know.
chocolate?
No.
Did it dissolve? Did it start dissolving?
Yeah, I guess you can say the water got a little murky.
What about when you took it out on the paper towel? What happened?
What was evidence of melting?
Okay,
not
because
dissolving.
we-
All right, so and what do you mean by evidence of melting? It was squishy.
Softer than
So how do you know it wasn't dissolving? chocolate?
Because the one that was in the cold water wasn't squishy.
Well, the chocolate didn't separate. It was still there, but
It was chunked up on the side. Like
So I guess this comes down to how would you describe to children what dissolving is?
You're doing it now. You're talking about it and making sense. We're not there yet.
I think the difference would be for melting, it stays in place. It doesn't move
it
out.
stays together. It doesn't
Yeah.
go into another.
Not always though.
Not always.
Think about a candle.
Let's just stick with
On
dissolving, right? Just stick with dissolving. Is the chocolate, okay, I think what I heard was that the colored coating did dissolve, right? And the dissolve, you could tell the evidence for the dissolving is the color stayed in the water or started to go into the water, even though it stayed at the bottom right now. The question is did anything else dissolve? So do you think that the chocolate dissolved? Do you have evidence that it maybe dissolved or maybe it didn't dissolve?
Maybe it did, but from the evidence, I would say no.
Okay, and what evidence do you have that you would say no? And we maybe should have kept the water a little bit longer.
Sorry.
No, that was my fault too.
Yeah.
No big deal.
If we came back tomorrow, it probably would have.
Okay, it probably would have dissolved. All right, but what might give you some indication that if you came back tomorrow, it might dissolve?
The
The
water's
color's gonna
cloudy.
change.
The water. I agree. Your water was a little cloudy, but what else about the chocolate? Was it the same when you put it on the paper
Oh,
towel?
the piece is gonna be smaller.
The piece was smaller. I think you could see that it was the chocolate maybe started to dissolve, maybe a little, but most of it stayed kind of in a blob, if you will. But some of it was squishy, as some of you said. Some of it wasn't. So what we want to look at is dissolve. It's when a material is placed in a liquid and the solid disappears into the liquid. We're not going to talk about. We're going to continue that conversation about disappears because that's what students are going to see or talk about until we say that the solid dissolved. They're going to develop that dissolved later on in 7.2 and 8.1, and that's where we're going to leave what happened with the dissolved for them to understand what dissolved is. Right? What about the two candies in the cups, the top cups? What happened to what about the, can't, say that again?
We're talking about the salt. Sorry.
No, go ahead.
What was the question again?
What happened to the two candies in the top cups?
Oh, we were talking about the dissolving.
This
One
one
of them
had
had
them.
one. They looked the same originally, but what the inside melted.
Yeah.
On the
so
hot
On the
candy
hot
coating
water.
didn't.
This group actually gave a better indication because yours actually cracked. The other ones didn't crack, right? But then you knew there was a difference when you put them on the paper towel, right? You saw a difference. All right, they cracked. It was soft, gooey. The one over the cold water, how did that stay? Stayed hard. It stayed like the way it was from the beginning, right? Stayed hard. All right. What happened to the candy in the water after the color coating dissolved? Again, the one in the hot water, soft and gooey. The one in the cold water stayed hard. So when we say that when a material, and this is changes state from a solid to a liquid, so in this one we're going to have an energy transfer happening to the material, it is called melting. Right? So when a material changes state from the solid to a liquid, the result of an energy transfer to the material is called melting.
Do we have a copy of that slide?
This is all
I will make sure they're in the folders, but I should already be in there.
Okay.
all in the folder, all right? And so this is just taken from the investigation.
I'm making
guide,
that.
the
I'm making
same
the calendar.
questions.
Note to that right now.
And the other thing that we added was what step it was on. So that hopefully is helpful too, similar to what the
See in the
teacher-
purple.
Teaching, yep, in the purple. So it'll stay step 10. Which I think that one I made a mistake is, no, that's step 10. All right, so what I want you to do is thinking about your data, I want you to think about comparing the difference between melting and dissolving. And I gave you, even though that says what is dissolving, what is melting, and the comparing, whether you want to do it on a little whiteboard here, or you want to do it on chart paper, whatever you want to do. So thinking about your data, your observations, understanding what dissolving and melting is. Let's think about a comparison between what is melting and what is dissolving. So where did you observe dissolving? Where did you observe melting? So do you want to write on the whiteboards? Talk as a group? So that they understand the difference between the two. And just, should be dry erase markers in there. Like I said,
Just read it.
So I do that as a sub stuff.
so thinking about where did you see dissolving and where did you see melting?
Do you understand? Like, just doing this. And then seeing, yeah, how to do both these on the same day.
So dissolving is like dissolving is
And I have larger boards.
I think in 7. Oh, this is supposed to be cold. 7 is solution.
Don't forget to say your evidence as to why you know that.
So I'm sorry. I got caught up. Okay. What were you supposed to do? Shot?
Can I use these on
No,
that?
no.
Yeah, we'll go off with the wet.
Okay.
Yeah, they're
What
wet.
was easier?
Okay, where did you?
That's the water.
Ready? Do you want a larger one?
Marker.
Either way, or I've got larger ones too.
Yes.
So whatever
I
makes
got a
you
blue
guys
one,
comfortable.
blue and orange. Do you want to use a busy?
I don't.
Visa?
Anybody want these?
Right on this?
What do you call it?
I said
Shannon,
busy.
did you have any?
Because I didn't know what.
Liquid. I
And
haven't gotten a response back
Oh,
yet.
okay. Oh, you reached out to them, right?
Yeah. Do you guys need markers? You might need markers. Dry erase markers.
They're wet erase. Do you have? Never mind, we got it.
We got these are dry. You need dry.
You guys have
That's dry right now.
Yeah, thanks for Kate. Okay.
Would some of these
Yeah.
questions for sections 3 and 4 be helpful? Because they have the diagrams.
Sure. Yeah.
Great.
I found a good website
Yeah.
on the shop.
Yeah, great.
Yeah, these were on Google Images.
We smashed it with our fingers.
Only melting, right? Gas station. Instead of
That was from my time frame.
but it was good with
On school print.
So I'll look
Like,
clear.
it's nice and like
Smashed.
Yeah, they're
It was writing the definition of dissolve.
Those are, right, so where did you observe dissolve?
Yeah,
And so is that
Oh,
one?
okay.
Yeah, she's all
writing Google Images.
Yep.
You're right, you're right.
Yeah, because you can't copy from the,
And what your evidence
assessments
is.
and
That's
costs
supposed to do. Okay, now it clicked.
into your own document.
It clicked.
You have to take a screenshot.
Yeah, it won't let
You
you
gotta
do
write
it.
it again.
That-
You can
this
take a
is-
screenshot.
That was the quickest way to do it.
Awesomeness.
Google Images.
Rain screen.
Yeah,
I like the easiest way.
Yeah.
So the evidence.
Easy and quick is all.
The
the
water.
thing.
yeah.
Thank you. Yeah, I can share that with you.
Why is your handwriting so amazing? I can't understand. Don't understand.
And while you're thinking, or while you're writing that, where did you observe
candy
dissolving?
coating was in
Where
the
did you
water.
observe melting? You
Close the
can
water.
use the other half of that student notebook sheet again, whether you want to print this for students or not. This might help guide them. So for example, what melted? Under what conditions? What happened to the particle level when it was melted? So bring them to that. So using this, I'm going to have you guys do both melting and dissolving and make a comparison. I know I changed my mind on that, sorry. Just to see where you guys are. So use this student notebook sheet if you want to help guide you on that.
The conversations are crazy.
White candy coating.
I'll be, I have to drop off something to Sabrina tomorrow morning, so are you guys testing for me? Okay, I was gonna stop by and listen to some of the conversations.
I mean, I've just finished, I'm
Did you do it for
straight lines. So, tomorrow on Friday, testing
I like that.
Yep, that's actually, was that the one on Foss or a different one? Because there is one on Foss.
Mr. Riddle.
No, I'm sorry, I said both. Yep, I changed my mind. I was gonna have one group do one, and then I'm like, no, go ahead and use the, questions on the student notebook sheet.
How fast it took you to write two
Like it
pages?
says in the conclusion, on the alternate signature, and I'm gonna reply, oh, well, I'm sorry.
Well,
That's gonna happen, right? Well,
Right.
did it resolve or no?
It's a finish, you got a finished product of 2 pages.
Candy
That's all that
corn
matters.
separated from candy
Make
corn.
adjustments
I'm glad to hear that.
afterwards.
Gotta make sure I can transfer.
I'm thinking that if you didn't drop those, you can transfer it all.
Yeah.
No,
there's like
I had a teacher who would spray it with perfume before she, good enough, and she would do it in front of them, but yeah, and then if they do eat it.
So you want us to say is the evidence of dissolving and also?
Absolutely, we don't wanna just say, so, you got that, and then how about going at that particle level, where it says up there, so in yours, what melted, under what conditions, and what happened at the particle level when it melted. Oh, that's what you were
Oh,
talking
they
about.
are immensely.
I didn't have any. Sorry if I was unclear.
No, you were clear, we just were lost at
Okay,
that,
it's long days, right? I get it.
at the particle level, so.
What happened at the particle level?
Because this whole module is about the particle level. When they're talking about energy transfer, all those things is at that particle level.
So in the hot one, the particles got excited.
Are we talking about
Yes.
dissolving?
Mm-hmm.
Okay, well, I was talking about melting.
Okay, and what about
Not
at
that
the
that would make
particle
any
level?
sense anyway, but.
Add some particles to that.
I'm just gonna say so.
The particles.
I like the Queen's kinetic energy. What about at the particle level? What happens that allows it to dissolve or melt? Or what's happening in dissolve?
Separate but
Moved? I'm sure that's a good word.
Yeah.
And then this one would be not moved around, but was transferred. Just talk.
Melting?
Mm-hmm. The energy was transferred from
Say your first name.
the liquid to the particle.
From what to what? So how is energy transferred? It's always transferred from
Yeah.
The hot water to the.
hot.
Okay.
How long will it take you to write your big paper?
Ooh, me?
Yeah.
I got better.
None sounds from me.
It'll take me about.
But not to like write it,
They don't
just
leave
to like
my
write it.
name. No, it's supposed to.
Like I already have it.
I can add a couple
Just to write it
No,
down.
no, but the way you're writing, I can tell you don't need to write it. Like you can flow. It doesn't really.
Oh, yeah, no, I can't, I never did,
They
like,
never
I
leave
still
my room. They
can't.
can never push it.
My
I
kids
have
come
no
home
idea
and
what
I'm
I don't think there's anything in it anyway.
Daddy got to make
T take T. Yeah. I can
Alright,
just
don't
tell.
make it up.
The way you write, I can just tell it flows out. It's not like it needs to be pieced together.
No, I can't, I've never been able to do that, I can't do it with my kids.
What's that?
Just talking about.
Flowcharts
pumpkin
and,
carving.
outlines for papers,
It,
it just does
it's
not
a
work.
gift for her. Just it just naturally flows for
Oh, it was
her,
last night.
and she doesn't have to
That's
stop
the
and think
door.
about the connection of whatever she's doing. So
Meanwhile, I'm sitting
You're
going, okay,
gifted.
how do I make a G?
Maybe in that area. That's about it.
All right, which group wants to
Could
start?
be a curse though, because now I
So let's look at all right, so,
I don't talk with my
all right, we do have a dissolving here. All right, so go ahead.
We said that in the hot water, the candy coated was dissolving in both cups, hot and cold.
She's automatically not it. You're it. You didn't pass me.
And we were saying that the particles in the hot water, were moving faster, they gained kinetic energy. And that's something we talked about over and over in 4, I think it was 4. And then in the cold water, of course, they were losing kinetic energy. Not moving as, particles weren't moving as fast.
Okay.
Cold water.
Do others agree or disagree on the dissolving part?
I would agree.
Why would you agree?
Because my information, the evidence that I wrote down, because the water is colder, there's not enough, I mean, not enough, but there's not a lot of energy to be transferred to the candy coating. So because of that, I would agree.
So let me ask you, what is your understanding of energy transfer? Students should already have an understanding of energy transfer.
Something
Well,
goes to
they will
something
once
else.
they do 5 right now.
Oh, sorry.
One, but
Pretending if we're on 7 already, correct. Actually, they started investigation 4 on energy transfer. What do they already know about energy transfer?
that it require just transfer of heat.
Transfer of heat, right? So is there actually energy transferring in the dissolving ones?
No.
No. So think about that, right? So when you're talking about at that particle level, there's not energy transfer going on, right? So what's happening? The particles are moving. What's happening? Go ahead, Mallory.
The water particles are just breaking apart the solid.
Exactly. So the water particles are hitting the solid, breaking it apart, and then what happens to the solid, or the candy in this case, which is the candy coating for right now, right? So what happens to those candy coating particles?
They get dispersed in the water.
They get dispersed in the water.
But they're heavy, so they stay to the bottom.
Right
they're
now.
Not a technical liquid. They're just small little bits of solid inside the liquid.
Right.
Right.
So your students may not quite get where Mallory just went, but what you want them to understand is that the water particles are hitting the candy particles, which you can tell them is sugar. They've used sugar in their investigations, and so those are breaking apart, and so you can even have them start drawing what that is. We do ask you to do that a little bit later. Is it starting to break out? But you notice that it's all at the bottom. If you did leave it set overnight, they could come back and see what it happens. You should see it. I don't know how fast it is. Some of them it could take days if you don't stir it, right? It could take days where then the whole water should be the same color of the candy, but if you noticed it wasn't there. So right, so the particles are banging, the water particles are banging into that. We don't have an energy transfer, and they're becoming part of the water, right? That's why it's dissolving, right? And it dissolved in both the hot and the cold, so that's key, right? Because you don't need what in order for something to dissolve, right? You don't need heat in order for something to dissolve. All right, what about the melting? Who wants to talk about the melting? What melted? What group? And Anto, go ahead, you start.
The chocolate melted. The candy coating did not melt, it dissolved first, and so that's why in the cup it looked normal until you pushed on it, because the candy coating broke with the pressure and the chocolate melted. Melting would be an increase of kinetic energy, which they should know.
Right, they should already, you already started talking about kinetic energy.
Just like a thermometer, the inside.
Right. Exactly, bring it back to things that they've already done. Perfect.
The kinetic energy increased, so therefore the particles started moving faster and expanding, and therefore became liquid-like. They'll tell me it's not a liquid, because they would think of it as flowing, but the longer you let it melt, the more like it would become
liquid-like, right? All right. And so what was needed for something to melt? Heat, right? So one of the things is that when they get to that, what did you observe about that? And then starting to show the differences between dissolving and melting. What are some of the key things that dissolve, or let's start with melting. What is one of the key things about melting?
You need heat.
You need heat, right? So there's a change in heat, and with the heat increases the speed of the particles, which is an increase in kinetic energy, right? So heating increases the kinetic energy. It goes from the solid. If you left it, was it a liquid? No, because we didn't leave it long enough, and it probably, I don't know that it would ever get to a liquid. Our cups would melt before that. But then in the dissolving, then what you can say, and this leads into the next part, is the dissolving starts dissolving in there and it leads to a solution, right? We don't really have a solution yet at where we were going on the dissolving, but we were headed towards a solution. Does that make sense? So this is tough for students, but the key thing is to let them know that those particles are moving in both cases, but in one you need the heat in order for that energy to transfer, and that is melting, not dissolving. So when students say, oh, what's something that they say, because we, not just students, I can say adults too, about melting and dissolving. Something melted in, like the sugar melted in my coffee, or did it really melt in the coffee, right? So you might bring up some examples and then ask them, did this really melt? And then they move on from here, and like I said, then you want them to go to make a drawing in their notebook to illustrate what you think is happening and start getting them at that particle level. Then from there, they go into leading into solubility, right? So I'm going to read that. And then after they do the solubility, I just wanted to bring this out, then they read about how things dissolve. So they don't read about how things dissolve in 7.1. They read after you do 7.2, right? And then they're kind of come back to, this is a good example. And you could even set this up if you want, where they have the candy and they let it dissolve, and it actually shows it takes 4 days. I was kind of shocked that it would take that long for it to actually become a solution. And then they bring in words like the solute, solvent, things like that. So that's when those words come out. And then they get to that particle level of what's happening when it's dissolving, right? So they don't talk about melting as a chemical change per se, just because not all things that melt go under. I mean, sorry, not melting. What was it? What was I reading? So dissolving. And so depending on how you guys have brought in
That would be a
physical change, right? So you may want to ask them what's happening with both dissolving and melting, because you guys have already covered physical changes and chemical changes. And that's 7.1 and 7.2 happening. And that's it. So questions?
There's only two sections to 7.
2 sections to 7, and that's it. So the second one is, and I've got the second one is they look at solubility, and they're going to look at calcium carbonate and sodium chloride. And so they're dealing again with the wells, and they're looking at before mixing, after mixing, and evaporation, and what happens. I have these sheets if you want what this looks like. Go ahead.
Right, so in a while the ground then we'll have
That's
sodium carbonate.
Not calcium carbonate, not sodium bicarbonate. Calcium carbonate and sodium chloride. Yeah, so they're going to look at solubility. That'll lead to solubility, and they're going to look at the wells again, and then mix them up. So, and they'll look at and then they'll look at that, and then there is a, if you look at, I don't know if you have your investigations out. On page 335 is what I was talking about, where how things dissolve. There is also a online activity where it gets to that particle level. So if they haven't drawn at that particle level on what they did in the M&Ms, they could add or make another drawing. Is they look at exploring dissolving, and there is a piece there. And actually, I like the reading on dissolving. I think it's a nice. And then after that, then they also look at I think it was concentration or something. Or maybe that's it. And that wraps up investigation 7. So it's pretty short. Investigation 7.
So we do basically 5.2,
5.2,
7, 8, and 9.
7 and 9.
With this.
Right.
Not-
Oh, 8.
8, yeah,
8,
8 and 9.
7, 8, and 9.
And that's it.
That's chemical
So
interactions.
that'll bring us to about just before Christmas. So all of November for 7 and 8, and then start of December for 9. We're supposed to start
I'd have to look at the actual pacing.
Yeah, eight has, like, I think, has 4 parts. So 7 should be, 5 will be quick.
So we should be starting electromagnetism next after chemical interaction.
I can't use my computer a second, but I can look it up on my phone.
I think so. I was
I
looking at
think
that
you're
one the other
correct.
day.
We get new,
Right
yeah. You'll do you guys
Yeah, electromagnetic.
1.1.
That one switches, there's some things that happen in that one.
Yeah, that 1 point investigation 1 of the next 2 kits before the end of the semester.
In January.
Okay.
That's why they took out
I'm glad that
6.
verbal cut out 5.1 and 5.3.
And are we gonna have access to this midterm like we did last time?
Alright, so any questions? Couple of the teacher tips. One, like I said, the index cards that they do, you come back to them on investigation 8.1. Make sure that when they are pouring the hot water, that it's not too hot. So you might want them to take a temperature, and when it reaches a certain temperature, you can put them, I think Mallory had a good suggestion, put them in the styrofoam cups, have them read the temperature, because I noticed when I was in classrooms that students do not know how to read a thermometer, believe it or not. Not saying all students, but there were several who could not. And so maybe having them read, and when it got to a certain temperature, they could pour it into the clear ones. And shoot, you could actually melt one and show them what would happen. Whether you think students would try to mimic that, or that would deter them from doing it. All your cups already melted? Alright, so.
I mean, they're just disarmed at the bottom, they still hold things, but.
Yeah. And so that might be something then, using a skill on how to read a thermometer before they put it in. I'm not sure what temperature, they didn't say anything in here at what temperature.
Would be too hot.
Too hot, yeah.
That's what I wondered about.
Yeah, I did it with Mr. Riddle's class, and it didn't melt at the 4. Is that when yours melted?
Yeah.
Yeah, his didn't,
Coffee pot's too hot.
we didn't melt any.
How did you get hot water?
We used a hot plate.
Oh, see, I used
Yours must have been
I had a
boiling.
spigot on it for.
Yeah, I'm
Like hot water,
surprised.
like coffee and stuff.
Yeah.
Like an urn.
Yes.
I will look and see if there's a temperature. I'm surprised they don't list that. There may be something in here that I missed. I didn't see anything on what temperature would be too hot, because it will melt the cups, which I thought I had seen that in something else.
Next Tuesday, are we doing the next one? Is that going to be this
Kip will be here.
So,
That one.
Yep, and so based on that, actually, you are a perfect segue, is if you guys could take a minute and on a sticky notes, the next Tuesday we'll be working with notebooks. So the whole PD will be focused around notebooks, but we'll be doing, I think we're going to do investigation 8 is the idea. So what are some things you would be looking for with notebooks? So if you could take some time right now, and that'll be thinking of that, your exit, so if you need water.
Yeah, they're wet.
Okay. So go ahead and give
What
as
is the
many,
major difference?
many suggestions as possible.